This video is on scalars and vectors. Part 1, define the following terms. Magnitude. Magnitude means number. It's the length or the number of a quantity. It's the distance from the origin, and it's always positive. Like I have 7 potatoes. We're 8 kilometers from home. A scalar is a quantity which has a number only. It has no direction. So we'll see some examples on the next page, hopefully. Question 3, vector. A vector is a quantity which has a number and a direction. The symbol for a vector is an arrow shown above the variable. So these are 3 examples: displacement, velocity, acceleration. In some books they can make them bold font, and sometimes you cannot make them bold. So you just write the symbol like A and you put that arrow on the top. Part 2, determine if the following quantities are scalars or vectors. So you have to ask your teacher which one of these variables you're going to learn. So no need to memorize all of them. So money is a scalar. Question number 1. So if you have like $10 and you add $10 to it, you get $20. You don't say $10 north plus $10 south equals $0. That's not how money works. Question 2, the perimeter, which is a distance around a closed object, is a scalar. You never say the perimeter of the circle is 5 meters east. Question 3, circumference, that's the distance around a circle. It's a scalar. It's just a number. You never say the circumference of a circle is 25 centimeters north. Question 4, area is a vector, which is quite surprising, so memorize that. Question 5, volume is a scalar. You never assign a direction to the volume of an object. You don't say the volume of the house is a few thousand meters cubed west. Question 6, angle is a scalar. Question 7, time is a scalar. Question 8, distance is a scalar. Length is a scalar, distance is a scalar. Question 10, displacement is a vector. So for example, we could say 10 meters west. That's the displacement. If we only say 10 meters, that's question 9, distance. Question 11, speed is a scalar. 12, velocity is a vector. Question 13, acceleration is a vector. So we're accelerating 3 meters per second every second north. That's acceleration. Question 14, force is a vector. And you could pause the video. You could write all these down. Energy is a scalar. You never say the banana has 50 joules north. You just say the banana has 50 joules. Power is a scalar. Question 32, specific heat capacity, that's a scalar. It's just a number. Question 42, current is a scalar. Memorize that, because you might say, well, the current might be 0.2 amperes east or 0.2 amperes west. But we define current to be a scalar. There's more to it, which we don't need to get into. Question 56 and 57 is about radioactivity. Half-life and activity is a scalar. Part 3, drawing vectors. Use a pencil and ruler. So let the vectors A equal 3, minus 2, and B be minus 1, 4. So part A, draw a horizontal and vertical axis on the graph below. Label the horizontal axis X and the vertical axis Y. So we get something like this. Part B, draw A on the graph below. So A is going to be 3, minus 2. So A is going to be 3 to the right, 2 down. So this is A. Part C, what is the magnitude of the horizontal component of A? So that's going to be the, it says horizontal component, so that's 3. Part D, what is the magnitude of the vertical component of A? Remember, magnitude is a number, no direction. It's always positive. So the answer is going to be 2. Part E, what is the magnitude of A? That's the square root of 3 squared plus the square root of minus 2 squared, which is the square root of root 13. So part E, they're asking for this distance. What is the distance of A? What is the length of A? We have 3 to the right, 2 down. We could use Pythagoras' theorem to find that this length is the square root of 3 squared plus the square root of minus 2 squared. Part F, draw B on the graph below. So we're going to graph -1, 4. So 1 to the left, 4 up. Part G, what is A plus B? Well, A plus B is going to be the x component plus the x component, comma, the y component plus the y component. So we have 3 plus -1, which is 2, and -2 plus 4, which is 2. So that's A plus B. And we could draw it on the graph below. 2, 2. Part H, what is the magnitude of the horizontal component of A plus B? Well, the horizontal component is going to be 2, and the magnitude of the vertical component is going to be 2. So if you want to find the solution for H, you got to look at G. And if you want to find the solution to I, we have to look at G. Part J, what is the magnitude of A plus B? That's the square root of what we get from part G. 2 squared plus 2 squared, which is root 8. Part K, what is B plus A? Well, like I said, that's the x component plus the x component, comma, y component plus the y component. Part L, what is A minus B? That's x sub A minus x sub B, comma, y sub A minus y sub B. Part M, what is B minus A? That is x sub B minus x sub A, comma, y sub B minus y sub A. And N and O follow the same pattern. So this is what we get from, this is the solution from all the graphing problems. Part 4, answer the following questions. This is the classic boat crossing a river problem. So Adam is on a boat. It's moving from south to north on a river at a speed of 9 meters per second. The water on the river is moving from east to west with a speed of 4 meters per second. The river is 81 meters wide. So part A, draw a figure. This is my figure. Okay. Part B, how long will it take for the boat to reach the other side? So if Adam is going 9 meters per second north, that's the speed, and the distance, or the length of the river, is 81 meters, we could use this equation, y equals vt, where y is the vertical distance, v is the speed, and t is the time. So we get 9 seconds. It takes 9 seconds to go from the bottom to the top. C says, how many meters will the boat have traveled westward? Well, you know that there's a current that goes from east to west, which is 4 meters per second. So x equals vt. Well, the speed is 4 meters per second west, and the time it takes for the boat to travel is 9 seconds. So multiply the two, we get 36 meters west. So Adam goes 81 meters north, 36 meters west. So we have this triangle here. Y on the vertical, X on the horizontal. Part D, what will be the total displacement of the boat? So displacement has a number and a direction. So the displacement is 81 meters north, 36 meters west. We take Pythagoras' theorem to find this direction, this distance. Square root of 36 squared plus 81 squared gives us 88.6 meters. And theta, we could do tangent inverse of x over y. Because we're looking at this triangle here, it's going to be x over y. Gives us 24 degrees. This is a very classic problem, so please try your best to understand this perfectly. Question 2, once again, this is the classic boat crossing a river problem. If you could do problem 1, then hopefully you could do problem 2. Enoch is on a boat. It is moving from north to south on a river at a speed of 6 meters per second. The water in the river is moving from west to east with a speed of 3 meters per second. The river is 99 meters wide. So part A, draw a figure. Done. Part B, how long will it take for the boat to reach the other side? So y equals vt. Y is the vertical distance. V is the velocity in the vertical distance. T is time. So the vertical speed is 6 meters per second. So solving for t, we get 16.5 seconds. Part C asks, how much do we go westward? So it's going to be 16.5 seconds times 3 meters per second west. There's a small mistake. The water in the river is moving from west to east. So this should say eastward, not westward. No, I apologize. Westward is correct. So moving from west to east. No, this should say eastward. This should say eastward. Finally, the displacement is exactly like the procedure from the previous problem. Question 3. A boat heads directly across a stream which has a current of 4 meters per second and which is 650 meters wide. The boat has a speed of 9 meters per second when it travels in still water. What will be the displacement of this boat when it reaches the opposite shore? So look at the image. First solve for the total time it takes to cross the river. And then we're going to use this equation, y equals v sub yt, to solve for the distance it goes downstream. And then finally, we could find the displacement and theta, which is tangent inverse of y over x. Question 4. A boat which has a speed of 9 meters per second in still water would like to reach a point on the shore directly across a river to the east. The river has a current of 3.5 meters per second downstream, and the river is 550 meters wide. Part A. In which direction should the boat be aimed in order for the boat to head directly across the river? So this is what we do. first we have x final equals v sub xt. And now we have this equation in green. It has two variables with one equation. And this equation is not necessary, the one in green. So we just look at the second equation. The second equation says y final, which is the vertical distance, equals v sub y times t. We want y final to be 0. So y final is 0 because it doesn't go up or down. And this first term here, 9 times the sine of theta, that's the objects, that's the boats going 9 meters per second times the sine of theta. And then this 3.5 meters per second times the sine of 270, that's the currents, the water going downwards. So this is v sub y in this big parentheses here, times t. So we just solve for theta, and theta is 22.9 degrees north of east. So north of east means you point eastward, and then you go 22.9 degrees north. Part B, how long will it take the boat to reach the opposite shore? Well, we're going to use this green equation that we have up here. And we've already solved for theta from our previous problem, so we just solve for time. Part C, an airplane which has a speed of 235 miles per hour, heads directly west. The wind in turn is blowing due south with a velocity of 45 miles per hour. What would be the velocity of this airplane as measured by an observer on the ground? So let east be 0 degrees. Counterclockwise is the positive theta axis or degree axis. One cycle or circle or revolution is 360 degrees. So east is 0, north is 90, west is 180, south is 270. So we're going to add the velocity of the airplane plus the velocity of the wind. So v sub x is going to be 235 cosine 180 plus 45 cosine 270. We're going to use cosine 180 because the airplane is moving westward. And we're going to use 270 for the wind because the wind is south. Totally south. That's what the problem says. So we get v sub x, and you notice we use cosine, and then v sub y we used sine. Then to get the magnitude, we take the square root of v sub x squared plus v sub y squared. And then we get theta equals tangent inverse of v sub y over v sub x. So the answer is 10.8 degrees south of west. That means we point westward, but we go south 10.8 degrees. Question 6. An airplane which has an airspeed of 575 kilometers per hour heads directly east. So east means 0 degrees. The wind is blowing with a velocity of 82 kilometers per hour heading 35 degrees west of south. So that means we point southwards, but then we're going to go west 35 degrees. So that's going to be 270 degrees minus 35 degrees. What would be the resulting velocity of this airplane as measured from the ground? So once again, let east be 0 degrees. Counterclockwise is positive theta. One cycle is 360 degrees. So we're going to add the velocity of the plane plus the velocity of the wind. So this first term, 575 cosine 0, is the velocity of the plane in the x direction. 82 cosine 235 is the velocity of the wind in the x direction. Then v sub y gives us the velocity of the plane and the wind in the y direction. I just turned the cosine into a sine. Then finally we could take the magnitude. And then theta. Question 7. In order for an airliner to arrive at its destination on time, it must travel due west, which is 180 degrees, with a velocity of 475 miles per hour. However, the wind is blowing due south with a velocity of 65 miles per hour. What should the airspeed and heading of this airplane be in order for this airplane to arrive at its destination on time? So this is what we get. V cosine theta plus 65 cosine 270 equals the solution, 475 cosine 180. So this first term, V cosine theta, is for the plane on the x-axis, or the horizontal motion. 65 cosine 270 is the velocity of the wind in the x direction, horizontal direction. And 475 cosine 180 is for the horizontal direction, sum. V sine theta plus 65 sine 270 equals 475 sine 180. This is for the vertical direction. So now we're going to divide the two highlighted equations. And we get cotangent equals 475 over 65. Solve for theta, we get 7.79 degrees. So now we could plug this green solution into a yellow equation, and we get 480. Question 8. In order for an airplane to arrive at its destination on time, it must fly with a velocity of 985 kilometers per hour and a heading of 35 degrees east of north. So that means you point eastwards and then you go north 35 degrees. I apologize. That means you point north and then you go 35 degrees east. So that's going to be 90 degrees minus 35 degrees. However, the wind is blowing with a velocity of 155 on a heading of 12 degrees south of east. So that means you point eastwards and then you go south 12 degrees. So that's going to be minus 12 degrees, or 360 degrees minus 12, which is 348. With what velocity should the airplane fly in order to arrive at its destination on time? So here we have the horizontal component. Here we have the vertical component. We have two equations, two unknowns. And you could see this right fraction just gives us a number. And then the left fraction, the v's cancel. So we could solve for theta. Now we could substitute this theta back into the original function, highlighted in yellow. And we could find the solution.